Thank you everyone for coming. My name is Kat. I am representing N26 as a senior software engineer on the authentication team. I just want to give a quick thank you to DevOps Days in Marseille, DevOps D-Days Marseille, for organizing this really lovely event. It's my first time in France for a tech conference. And yeah, I'm very, very impressed so far. French people definitely are very much more put together than the rest of us. I've seen so many like sport coats, sweater vests, really things that you would not expect at a tech conference. And I don't know where all my free t-shirts are, so it's gonna have to file a complaint there. So yeah, I'm talking to you about building multi-region CI/CD pipelines with a DevOps mindset today. It's a lot of words, but effectively N26 launched in the US earlier this year, and there were a lot of, it was a huge kind of task for the entire company, and there were a lot of infrastructure changes and application changes and structural changes throughout the entire company to make this happen. And I'll be talking about one of those today. So, quick agenda. I'll be going through a quick introduction of N26, of the company and the infrastructure. Then we'll go into the problem statement, which is launching in the US, which is where this need for a multi-region CI/CD pipeline originated from. Then we'll talk about where we can actually configure the application for multiple regions. So do we do it in code, in framework, or in infrastructure? Then we'll talk about the actual implemented solution and finish up with some lessons learned. So I hope some of you are familiar with N26 because France is actually N26's second largest market, I think. There's like over 1 million users. But if you've never heard of it before, it's one of Europe's largest online-only consumer retail banks. You can sign up in 8 minutes, and when you do, you get a complete bank account with a debit card. We also have a bunch of cool features on top, like shared accounts, consumer credit, savings, invest, insurance, premium tier accounts, and features as well. They launched back in like 2013, so a relatively new company, but one of the first, I would say, companies that started this wave of neo-challenger banks all across Europe and the US. What is my role in all of this? So I was a senior software engineer at N26 for over 3 years. I'm actually no longer at the company, but I left a little bit earlier this year, but applied to do this talk before I left, so here I am. I'm originally from the US, and I've moved to Berlin a little bit over 4 years ago. Why do I think that I'm qualified to talk about anything multi-regional or pipeline-y? So I went to New York City actually in late 2017 for a few months to help open up the office and kind of talk to banking partners and card processors to kind of start the talks about what a technical implementation of a US bank would look like. I came back in 2018 to lead the authentication team. So we deal with all things user credentials related, third-party authorization, session management, so on and so forth. And my technical interests mostly revolve around distributed architectures, making them reliable and scalable, and security. So very back-end heavy. This color is so ugly. Okay. So this is a look at our previous deployment pipeline to one region. So whenever you push to any branch, we will always be continuously building the artifact and testing it. Once the code is merged, we again build it and run the integration test on it. Then we also run a series of kind of code quality scans with SonarQube, security reports for CVE scans. Then all of our services are Dockerized, so we'll build the Docker container and push it to the internal registry. Then it'll be deployed to our development environment. So dev is open to all devs for modification. Most devs have like admin privileges in here. And so we make sure that the service can come up healthily in dev, and if it does, then we proceed to go to staging. Staging is closed and audited for QA for testing, so this is actually a banking requirement to have some non-production environment that's also audited. So we take a lot of care in making sure that staging is very, very stable. And once it's deployed to staging, we again make sure that it can come up. and then we run a lot of end-to-end tests on it. So this is service-specific end-to-end tests, this is regression tests, this is smoke tests. We make sure that nothing is actually broken, and if nothing is broken, then the code is going to go straight to live, most of the time. And live is obviously closed, very heavily audited, and only accessible for incidents. So we do like to practice continuous deployment, which is somewhat surprising sometimes for a bank, but we do find that this actually does minimize errors as long as you have the sufficient testing infrastructure in place. Something else, so N26 has over 90 domain-specific microservices in backend and data. Each service talks to at least kind of 3 AWS dependencies, so everything is deployed on AWS. And previously, everything was hosted in EU Central 1, and these details will become very important very shortly. Like right now. So N26 in the EU has an EU-wide banking license, right? So this means that all of the users living in Germany, France, Spain are all part of the same legal entity. So this is why we are allowed to host everything out of EU Central 1. And in 2017, when we had gone over to the US, first thing that came abundantly clear was the fact that US US customers are not part of the same kind of legal entity, right? N26 US has its own legal entity. And as a result, we cannot store the users in the same data center. These need to be physically stored in the US and be completely separated from the US users, EU users. So this obviously adds a whole level of complexity to a very already complex solution, which is launching a bank in a new country. And while, yes, cloud providers like AWS, GCP do make it a lot easier to kind of set up a new data center by taking away all of the need to manage your own hardware and virtualization software, it's still highly, highly non-trivial to bring up a data center from scratch, right? So what kind of things do we need for this? We need new VPC networks, security groups, we need new AWS resources, roles to actually manage those resources, we need new secrets clusters, logging clusters, containerization clusters, service definitions, the list goes on and on and on, right? This is obviously non-exhaustive. And then at the same time, we also need to get all the services that are running in the EU also deployed to the US as well. So again, this is something that really affects the entire company, and it's a huge, huge project. So ultimately, the question is, like, how do we achieve this US bank launch while annoying the fewest people possible? Because at the same time, N26 was going through a massive growth phase. We were adding probably like 15, 20 new developers every single month. The teams were constantly switching. And it's just not feasible for us to say, okay, everyone, like no one can deploy anything for 6 months while we get this data center ready, and then everyone like all of a sudden move your services over, right? So really, like, how can we have all these infrastructure changes ongoing while keeping the applications running as smoothly as possible? On a more technical level, the question is, like, what are the clear boundaries between application and environment, right? And this is actually quite a common problem or common question in industry software engineering. I think you should be always asking yourself this all the time. Every single time you build a component, you should be saying, how do I build a clear interface that it's clear but also hides complexity of what's actually going on? And so to answer this question, let's zoom in from the global kind of map to directly down to the application hierarchy itself. So 2 things about this application hierarchy. First is I never claimed to be an artist of any kind. Well, like only an artist of code, really. But no, so this is actually done in Excel. It's like not the prettiest graph ever. Someone at a previous conference said, you know, Excel is somehow the second best option for any job done, and so now you can kind of add diagram drawing to this. The second thing is I made up this application hierarchy for the purposes of this presentation. This is by no means like an authoritative guide on how you should like think about applications, but It works for me. If you disagree, we can talk about that afterwards. So the first is the top layer, you have your code. So your code is usually running your business logic, and your code usually runs on top of some kind of web framework, right? And at N26, it's very JVM heavy, so this is mostly Kotlin running over Spring Boot. It could also be Python over Django, like JavaScript over Node, C# over .NET, PHP over like something. And yeah, these two layers are typically what make up your application, right? So if you are a backend developer, I think I am a backend developer, I think most of you maybe are in like SRE. These are usually the two layers that we as backend developers care about, right? So you have many applications running within a certain environment, and I consider this environment just to be kind of like a container of all your applications, right? And then below the environment is the configuration management and machine provisioning. This happens typically what we call like the infrastructure layer, and this is what we have DevOps and SRE people for, right? And they kind of define the environment variables that are fed into the environment and then exposed into the application to use. So in theory, adding a new region should actually only affect configuration and not code. And this is a concept that is true even when you deploy things from dev staging to live, right? The code between dev staging and live does not really change. What does change are your configuration variables. So let's make it a little bit more concrete. Let's say we have a user service, and this user service, again, has, let's say, 3 external dependencies that need to be configured for every single environment. You have some, maybe it talks to some queue on SQS, so you have like a dev EU specific queue name. It talks to a database, and it reaches the database via also some dev EU specific connection string. And it also maybe uploads things to S3, right? So you have a dev EU specific S3 bucket. And our job now here is to take this user service and deploy it into the US region and also have a US dev staging and live. Because again, we want all of our environments and regions to be as homogeneous as possible. So for the rest of the presentation, I'm just going to be focusing on the database connection string, but do keep in mind that everything here kind of applies to any kind of configuration parameter that you have. So how can we configure this application in a way such that it's easy for us to reach this connection string? Well, let's try, how about the top layer, which is configuration in code, right? So we get the environment, so we get some env and region variable from the environment, and then from there, we have just a bunch of if-else-if statements, right? If it's dev and EU, then take the dev EU specific connection string. If it's staging and EU, take staging EU. Live EU, so on and so forth, and same for the US. And that will work for the most part, but it's obviously bad, right? Because configuration now is indistinguishable from your code. This is a violation of the 12-factor app, and that is the authoritative kind of guidelines on how to build service-oriented architectures. And it's bad because like adding a new region forces the application to change. You have to recompile it, you have to redeploy it, and it's very prone to errors here. So this is not great. Okay, then let's push it down a little bit, right? Let's push it down into the framework. So again, this is a very Spring Boot way to do things, but I'm sure it's the same, relatively similar in other frameworks. But you basically have a series of configuration files, and each file kind of maps to an environment. So again, we have EU dev, live and staging, US dev, live and staging. And within the application itself, this is where we would actually put the connection string. So everything is keyed by spring.datasource.url, and then, yeah, the actual string here, this is where it's defined. This also makes our code much easier and simpler and cleaner, because all we have to do now is take the key, and then Spring will actually inject the variable for us. So the application itself does not actually need to care about how to connect to the database. So this is better. And this is also the way that we did it for a long time when we just had dev, staging, and live. And because, yeah, configuration is separate from the code, and it's still mostly controlled in the application. But if you let n equal the number of environments, m equal the number of the regions, then the number of application files grows as a function of n times m, right? Which is not great. And you can already see here, like we only have 2 environments and 3 regions. We already have 6 files plus like a constant 3 for a default local and test. N26 wants to be a global bank, so once we launch to like a few more regions, we're gonna have like this crazy kind of just directory of application files, and it's gonna be really easy to misconfigure one, have a typo in another one, and it's not gonna be very pretty. So, okay, then there's obviously issues with this configuration as well. So then let's just like keep pushing it down, and let's say like, I don't want to deal with any kind of configuration stuff, right? I think configuration is actually the responsibility of the infrastructure layer. So this is an example kind of service definition. And at N26, we used Salt Stack for the infrastructure as code layer. I mean, it's, again, this is relatively tool and language agnostic. So you can say that this could be like Terraform. It could be CloudFormation, Chef, Puppet, Ansible, whatever, but there's some definition that takes environment variables for each service and then actually makes them available to the service itself. So in addition to all these kind of lower level environment variables like region environment and some things that we needed for SRE, here is also where we put the user database URL. And this is also not a bad solution. I can imagine that a lot of companies do it like this as well. And especially you can guess, like, if you have some kind of larger enterprise corporate company where they still separate DBAs from sysadmin, this is quite a reasonable solution, because you would just tell your DBA, I need a new database, and they'll spin it up for you, and they'll make it available to you at this environment variable, and then the application doesn't need to care about it at all. So this is, yeah, not a bad option. But the problem with that is that now it's completely managed by our SRE team, right? And SRE teams don't, SRE DevOps engineers actually do not exist solely for the purpose of like configuring applications for like product teams as much as we would like them to think that they do. Because the SRE team right now is very, very busy, you know, setting up the actual data center itself, right? They have to like configure all the Elasticsearch clusters, maybe deal with Nginx configurations. There's all these agents running underneath the applications. So you have like Datadog, console, packetbeat for logs, so on and so forth. So while they're pushing all of their changes to the Salt Stack repository, now there are all these new variables and demands coming in from the application layer saying, the user service needs a new SQS, S3 bucket, authentication service, maybe take some like Lambda function. And so this is also the SRE's responsibility to kind of put together and manage. So instead of mixing configuration with code this time, now we're kind of mixing infrastructure with application. And any kind of change to the application logic actually requires a pull request to the Salt Stack repository. And this is only merged and reviewed by SREs, right? And when I say N26 is going through a massive growth phase, it seems like the growth phase ever only applies to kind of like front-end web and back-end developers, right? DevOps and SRE engineers are always just like some rare gem, and they could just never be found as quickly. So it was really against like these 5 SRE engineers against 100 back-end developers, and it became a massive, massive bottleneck. And I'm talking like on the order of weeks, right? Because there was actually like, we couldn't complete tasks, and we couldn't even start tasks actually, because there's like, okay, our application, you know, still can't talk to the database, so we haven't even really started the actual Jira task at hand. So this was really, really slowing things down. And again, it proved to be kind of a very imperfect solution. So, I mean, we're kind of like out of layers here, right? No matter where we put the configuration management, it seems to not really fit. It seems to make whatever layer like a little bit too fat. So what do we do at this point? Well, I don't know if you're familiar with the 12 networking truths. It was an RFC that came out in like 1996. I think it was like probably, I don't know, first example of real meme humor on the internet. But number 6 of those is actually, so it's always easier to move a problem around than it is to actually solve it. And direct corollary is that it's always possible to add another layer of indirection. And that's actually exactly what we did. So this is our previous application hierarchy. You can probably tell where I'm going to draw the line because it's already separated by a nice and you would be correct there. So we actually separated the configuration management from the machine provisioning. And most importantly, we redrew the interface between application and environment because it's no longer, we're actually going to make it the application's responsibility to configure the parameters that are needed for the application. So this is previously what we had with just SaltStack. We had all these kind of actual infrastructure-related entities, and then also on top we had service environment variables and service AWS resources, and this is where all of the bottleneck came from. So what we did was we introduced Terraform purely for the configuration management portion of this, and so we moved all of the service environment variables and AWS resources into Terraform. And the best part about it is that this actually became team-owned. So we had to kind of onboard developers to teach them how to use Terraform, and then enabled them to make these kinds of changes on their own. And if you think about it, that's actually that's perfectly fine. That's probably the best solution, because who knows best what kind of resources a service needs, right? It's the service itself. There's no reason why SRE is the one that needs to be kind of giving an application permissions to like a new Kinesis stream, for example. Like this comes from the service itself. Last thing that I'm going to introduce is Consul, a service discovery and a key value store. If you're not familiar with Consul, well, right now is probably not the time that you're going to learn about it. We just don't have enough time to go into the details of it. But it's effectively like an Apache Zookeeper, where you basically have a cluster, a Consul cluster that runs, and you can kind of register components into Consul, and Consul will actually kind of track where the location is for you. And it also ensures that the service is healthy, and in case it moves, Consul will actually switch out the location for you, and then this is completely transparent to the application. So it's kind of like a managed environment variable in a way, but you can also update it at runtime as well. So what we did was we registered the database and also the AWS resources into Consul, and basically for every single environment, dev, staging, and live, the database is always reachable at users-database.service.consul. So this also made it much simpler. Now we've reduced that huge file list into just one application.yaml. So this ended up being actually the best solution for us at the time. So configuration here is now separated from the code, and application-specific needs are also separate from the infrastructure. And just a side little benefit, any kind of changes to these environment variables actually do not require a redeploy, thanks to Consul. But like every single solution, there's no perfect one, right? And that's like also one of the 12 networking truths. There's no such thing as one size fits all. So this is a more complex solution, right? There's more tooling set up, there's a lot more moving parts. You have to learn Terraform, you have to maintain a Consul cluster, and it only became necessary when we reached a certain size, right? We had like 90 plus microservices that needed to be moved from 3 environments to like 6 environments, and we also had like 100 plus backend engineers. So I would not recommend this solution for something that's probably earlier stage. It could be just more of a bottleneck, honestly, than helpful. But for the stage of N26, around like 2018, this actually ended up being the perfect thing. So the result of this is that the application is entirely unaware of region and environment. You're never going to see anywhere in application code like if US then this, if EU then that. The team actually owns the provisioning of these service-specific resources, and now the deployment pipeline is only done is done by just switching out region and environment. So it looks pretty much the same. And when it comes to the dev deployment, it will actually go to dev US and EU in parallel, staging EU US in parallel, and live EU US in parallel as well. So finally, the lessons learned here are that infrastructure as code is not just one layer that lives beneath applications, and some layers actually belong to SRE, while others should actually be the responsibility of the developer. And to me, this is actually like the heart of DevOps culture. It's to embrace the fact that you should not be blocked as a developer if you have some kind of configuration issue. You should be empowered and enabled to kind of fix these on your own. So it's not just about fostering communication and learning more things. It's actually about making your whole entire development process and lifecycle more efficient. So yeah, that's it. Any questions? I don't know if we have time for questions, but maybe we do. Cool. Okay, cool. Thank you.